Good morning, ladies and gentlemen, and welcome to this online session where we're talking about digitalization and telecommunication technologies for fully optimized renewable energy assets. So as you know, technology is growing at a very, very rapid pace. And even if we're going through a energy revolution, if you like, or an energy transition right now, the telecommunications transition and the technology transition is ongoing for a few decades now, and it keeps on improving. It is just simply amazing to see, the rate of R&D and change, and not only incremental change, but also leapfrog change. And we're here today to discuss how this technology change and this telecommunications change can also help us in the energy department and in the energy sector to be more competitive, to be more efficient, and generally to just better, if you like, optimize the assets that we have and the energy and the energy that we can produce. So with us today, we have here 3 companies that are actually like riding the wave of in the leadership of technology and communications. And I'd like to invite them to introduce the speakers so that you can get to know them a little bit better, because they're going to be giving us some of these trends, technologies, and tips, for what's going on and how the energy sector can take some of these technologies for our benefit. So first, I'd like to invite Kamal, please, from Nokia, to unmute your microphone and introduce yourself.
Thank you very much, and I want to thank ATA and Business Finland for giving Nokia this platform to address this great audience. Should we launch into the conversation, or should we? You want to introduce everyone first?
No, just introduce yourself, and then we'll launch into the conversation.
Good. My name is Kamal Ballout, and I work for Nokia, and I manage the business for Nokia in Middle East and Africa.
Excellent. Thank you, Kamal. And today with you, you also have a colleague, Gary. If I may ask you to introduce yourself.
Yes, good morning, good afternoon. Gary Conway. I'm based in Dubai, Australian national. I look after energy segment sales for Nokia, and the territory I cover is the Middle East and Africa. Thank you.
Thank you very much, Gary. Next, I'd like to ask Patrick from Varsila to please introduce yourself. Make sure you take the mute of your microphone. Go ahead.
Hi, good morning, good afternoon, everyone. Thanks, first of all, for the invitation from Business Finland and for the opportunity to able this webinar, and thanks for ATA to be an excellent platform as always. I'm a market development manager focusing on the Middle East, and my primary role is value proposition development with the usage of advanced modeling tools. I cover the Middle East region, which for us includes Pakistan, Iraq, and Afghanistan as well. I'm based in Dubai, and I'm very excited to be part of this discussion.
Thank you very much, Patrick. And I'd also like to ask Gary to please, Klaus, to please introduce yourself. If you can take the mute of your microphone, please. There you go.
Okay, hello everybody. So my name is Klaus Kansela. I'm a principal scientist in Technical Research Center of Finland. So I'm coming from Finland, and I have been working in the branch of energy and energy distribution like 20 years. Currently, we are doing lots of modeling and estimation of grid resources and grid flexibility, and this is something I will actually go briefly through in the presentation later.
Excellent, thank you very much. Okay, so we're going to prepare the presentations, and this is how it's going to go today. We're going to have a structure of presentations. First, we're going to hear from Nokia, that is from Kamal and Gary. Then we're going to hear from Varsila, from Patrick. And then finally, we're going to hear also from VTT, from Klaus. And we're going to hear about all these new technologies and how can they make energy assets more competitive. Some of the things that we'll be touching upon, for example, 5G, and all of these new technology trends, okay? And we want to thank our partners on this webinar, which is Business in Finland. As you can see, these are 3 Finnish institutions, that are like at the cutting edge of technology. So thank you very much, Business in Finland, for supporting us and for supporting content creation. And without just further ado, I'm going to leave you with Nokia, but just a couple of things. One, we are recording this session, so it's going to be available as they all are, okay? So that's no issue. You will get the materials and also the recordings if you want to see it again. 2, please use the chat to introduce yourself. We love to see who's there in the audience. Introduce yourself, your company, where you're joining from. And finally, for your questions, please send your questions through the Q&A box at the bottom of the screen, right? There is a Q&A box there. Send them through there, and we'll manage them at the end. We do have some time for Q&A. Okay, so we'll try and address as many as we can. Without further ado, Kamal, Gary, your presentation is ready, so go for it.
Very good. Thank you again, everyone, and I hope you can all hear me. It's a very interesting topic that we at Nokia are very passionate about when we talk about the role of technology in energy transformation. I think if we are to reflect on the journey of the energy transformation, you look 2 years, 3 years ago, of course, when we talk about technology, communication technology, IoT, that was not necessarily the top hot topic that we talk about. However, as the energy market is transforming, and the disruption that we see in the market has brought the technology of communication and IoT and machine to machine into the forefront of this transformation. So hopefully, what we're able to demonstrate today in this very short time that we have, along with our colleagues, is the role of communication technology that plays in really transforming the operation model and the business model of the energy industry moving forward. So if we look at, if we go to the next slide, please. If we look at what's going on right now in the energy industry, we see that this is there is a new business models that are developing. Very simply, in the past, how energy always worked, it was always based on a system. The system is generation, transmission, distribution. And that system has lived for a very, very long time and has served humanity for quite a long time. The focus in there was to make sure that we facilitate the transmission of electricity in a reliable way from the point it was generated to the point it was consumed in distribution, going through the transmission network. And most of the time, the role of technology, communication technology there was strictly being built on top of transmission in order for us to manage the critical role of the transmission network. What we see right now is that 3 business models are evolving, and that is widely triggered because the function of generation is moving from a centralized generation to distributed generation. We see renewable energy, distributed energy, distributed storage, taking a significant position in the new world of energy. So how does this impact our thinking? So the way this is impacting utilities from a business model, if we start from a very high level and then we go into technology, from high level perspective, this is impacting utilities, power utilities, into transforming toward 3 business models. Okay, sometimes these 3 business models are integrated within one company. Sometimes they are being split under different entities. But however, there is distinct 3 business models that are emerging right now. There is the wire business, the transmission, distribution, the wire business, which is really the utility as we know it today. This is not going anywhere. This business is, it's required because we have no other means to transmit electricity other than wire. So however, we need to make sure we have a system to maintain the wire, to make it more efficient, to make it more reliable. So that business is definitely staying. However, you look at this business, usually the operating margin of this business is very challenging. The liability is high. There is a lot of assets involved in this business, but nevertheless, it is one of the businesses that is going to persist as we move forward within this disruption. The other two business models that are evolving are the renewable energy, which is really every utility right now is thinking about the role of renewable energy, which can be very disruptive, by the way. Many utilities are looking at, what is my role in the renewable energy universe? Is my role to facilitate it, to enable it, to allow, to create a market where others can come in and plug into my network, or is my role to actually embrace renewable energy and I become the conduit, the actual deployer of renewable energy, and I introduce renewable energy to my grid. And then you see different utilities are making different choices along this business model. The third business model is the service enablement. And a lot of utilities are now thinking about how can I diversify my revenue? How can I create revenue out of my existing assets by selling additional services, appliances as a service, virtual power plants, the enablement of power transaction between consumers and users, and usually many utilities right now are creating a chief digital executive role to allow for this transformation to happen and diversify the business. Now, the underlying message here is that if you look at all of these three business models that are emerging, they share one thing in common, which is really they rely very heavily on pervasive connectivity. They rely very heavily on the ability to enable machine-to-machine connectivity, to make decision-making in the distribution, make sure that we have a split-second automation where we rely less on human and more on our ability to rely on technology to help us enable these models. So hopefully my colleague Gary is going to take you through what the technology does to enable these models. Okay, thank you.
Yeah, thank you, Kamal. I think it's really important that we do talk about the three different business models that Kamal mentioned there, and then how technology can underpin and make those models become reality and successful. Just to introduce Nokia, for those of you that don't or are not familiar with the modern day Nokia brand. Within Nokia, we have multiple solutions that we're able to bring to market. So gone are the days of the mobile phone many years ago. So within Nokia today, we're made up of predominantly a mobile networks division, IP and optical technology, Nokia Bell Labs, services division, and really a Nokia Bell Labs where we innovate and we're bringing solutions for the future. And a lot of our strategy is formed on what Nokia Bell Labs predict industries will need moving forward in the next 3 to 5 years. And I wanted to share some of that with you today when we're looking at telecom solutions for renewables. So Industry 4.0, the fourth industrial revolution, is underpinning how industries are digitalizing and transforming. The Nokia approach is based on some key pillars to enable the business models explained by Kamal. Networks that have to be reliable and provide critical connectivity. By that I mean more reliable than the service we get with our mobile phones today. The power industry cannot accept poor networks that could allow outages. So better connectivity than what we would receive as a consumer in a household. The technology needs to be able to be mobile, to pick up all sorts of sensors in the network, people, vehicles, static and mobile plants. So predominantly our strategy for digitalizing power utilities is around a wireless network approach underpinned with our optical and IP technology. Performance and reliability, I've sort of mentioned, we need to be dealing with low latency, high performance networks, super reliable networks, better than 5 nines reliability. And of course, critically important is security. Just in the news today was a water utility spurious attack in the States where someone was trying to contaminate the water via hacking. So security is paramount. We have to have a solution where vendors are bringing industry standard security, both at the box and at the network level. I think we're in an industry where we are at a sunset. We are still reliant on some what we call in the business legacy technologies. By legacy, I mean they're end of life. They're no longer being developed. The roadmap isn't being progressed for future usage. And you probably can't buy support from the vendors anymore. Now, these technologies have been fantastic. Don't get me wrong. They have a great part to play and they played a great part. But you know, whether we like it or not, the modernization of these telecommunication networks are going to be required to allow digitalization, to allow the business models that Kamal mentioned, to allow a adaptable, renewable capability to take place. So really, IP is coming whether we like it or not. And that's a message that underpins our strategy. I think you need to work with vendors that have an appreciation of the industry and have supported the industry. And if you look at the Nokia, you know, the Nokia heritage here, we've been with the power utility business from the PDH and SDH days, but we're also looking to what's next, what you need to invest in next to fully embrace 4.0 and the next generation networks to allow your business to transform. And these are the spaces we're in with our IP MPLS, our teleprotection over IP, and our private wireless solutions that we're bringing into the industry. Pick a technology that's going to serve your needs today and has a roadmap that is evolving into the future. There's a lot of technologies today that have no roadmap for the future or no clear roadmap evolution for the future. I guess that's my message to you. So what is required of the network? I won't go too deep here. There's 4 key steps to get business value, and underpinning it, the enabler, the foundation network, the high performance network is critical. If we get this right, we can then start developing the next phases of our digitalization to really truly get a 4.0 power utility infrastructure. It does include cloud. Don't be scared by cloud. There is local, there is edge, and there is a hybrid cloud solution that keeps your data safe. We know how to do that. Then after our high performance network, and we've got the ability via a cloud network to pick up all of those sensors, all of those points of presence that we're probably not leveraging correctly today, we can start adding value. We call it digital value, whether that be via automation, whether that be via analytics or a digitalized operations center. We can start adding business applications, optimizing the grid, optimizing our workforce, giving them tools that can give them digital messages and maps of their assets and their maintenance. And of course, optimizing all of our assets. Teleprotection is, of course, a critical aspect of any transformation. And I think it would be fantastic if you validated my underpinning of IP MPLS as a technology of choice with our private wireless. It's not just Nokia saying this. There's key vendors out in the field that are also underpinning this next generation network, this industry 4.0 network. And finally, forgive me, you wouldn't do this without testing it. You know, we are in a risk-averse environment. Within Nokia, we've got a fully set up innovation center where we, with our own products and third-party products, can fully proof of concept test whatever innovation, whatever journey, whatever digitalization, whatever network changes you want to take. Please speak to your local Nokia representative. This innovation center we can make open for you to come and use. And finally, forgive me, there is a little bit of a salesman within me. We've got a great brand. We're probably not the best at promoting our brand for what we do because most people think we still do mobile phones. But really have a look at some of these credentials of Nokia in the energy sector. You know, over 1,400 teleprotection circuits on IP, look at our revenues, and the Nokia Bell Labs Innovation Center to underpin everything that we take out to market. So we're working with over 200 power utilities. I hope you find this interesting on your transformation journey. We'd love to help you on it. That's everything for me. Please ask any questions in the Q&A and I'll hand you back to the moderator.
Thank you very much, Gary. Very, very interesting presentation. And I knew that you guys were doing other things, but it's true, you know, it's easy to remember Nokia when we had all one Nokia in our pocket. But that doesn't mean that, you know, technologies change. And I'm, you know, it's very interesting to see what you guys are working on with the energy community. So next, I would like to ask Patrick to give his presentation, and please keep sending your questions. You know, we already have received some, but keep sending them. We'll answer them at the end. Go ahead, Patrick.
Thanks everyone. First of all, I'm amazed how much similarities there are between the telecom industry and the energy industry when we talk about future of network design, infrastructure planning, and operation. And I hope that my presentation will be also a nice continuation of the very interesting topic that Gary and Kamal introduced. So Wärtsilä is also a Finnish company. We have nearly 200 years of history. The company is headquartered in Helsinki. We have our main production and R&D facilities in Vaasa and also operation in Turku. Traditionally, we are known as a marine and energy company. Our signature products are large-scale reciprocating engines. Sorry, I cannot switch the slides. I'm not sure if you gave control to me. Could you one back, please?
Go one back. Okay.
Yes. Yes.
Do you want to request again the control and see? Hopefully it works.
Yeah. Yes, now it will work. So apologies for that. This slide basically gives a visual illustration of our signature products. These are large-scale industrial reciprocating engines, which are mainly used for two purposes: to propel ships and also to generate electricity. Globally, on average, every third vessel, container ship, cruise ship, or LNG carrier runs on our engines. And Wärtsilä as a company delivered power generation capacity in more than 170 countries all over the world. In the Middle East, we have deployed 7,200 megawatt capacity, and that includes Pakistan, Iraq, and Afghanistan. And a great portion of this capacity is under long-term service agreements with performance guarantees, which means that we need to ensure the safe and continuous supply of our customers, who are utilities, mine operators, cement plants, and we must ensure that they always get the contracted amount of power. In the next couple of minutes, I want to touch base on two key topics. I want to say a few words on how we take advantage of digital solutions in power plant operation and support, and also how our energy management software helps the better integration of renewables into complex energy systems. So the digital transformation for Wärtsilä has started long before the COVID era with the adaptation of remote monitoring and operation support solutions. However, I have to say that this pandemic has been a real stress test for the industry, and I think in readiness we luckily tested positive. For more than 50 years, we are building and operating power plants in remote areas, far away from civilization, in the middle of the jungle or in a desert. These places, equipment supply, personal mobilization is very difficult and convoluted. In many of these regions, our engines are the only source of electricity. So the continuous and safe operation of them is absolutely mission critical. It's not only money, but human lives depend on that. So over the past couple of years, Wärtsilä has built out a network of expertise centers all around the world, which provides constant operation support and monitoring to 450 of our power plants. The main role of these expertise centers is to constantly do constant surveillance of operation, also to do predictive maintenance plans, and to provide 24/7 support for our site personnel. In Dubai, we have a regional expertise center, which supports 53 power plants in the Middle East and Pakistan. And we ramped up our capacity over COVID, seeing the increasing need for this sort of remote support. What it means that every power plant is equipped with thousands of sensors which feed data directly to the expertise center. We run predictive maintenance algorithm, and we are able to forecast the failure of a mechanical component here in Dubai before it happens in a cement plant somewhere else, and we can notify the site crew to take appropriate measures to prevent it from happening. And obviously this saves a great amount of downtime and maintenance works. In the energy industry, there are, although, service works which are inevitable and sometimes happen unexpectedly. So to deal with that, we've been using augmented reality tools like these virtual reality goggles, which you can see on the picture. Basically, we can put this on anywhere and see what's going on at the customer's site. We see what our technicians see. We can ask the right questions, and we can virtually guide our clients' hands onto the right tools. Basically, it eliminates a great deal of guesswork. It provides immediate response and saves a great deal of money. An interesting example that even under the Saddam era, Wärtsilä managed to commission a power plant completely remotely in Iraq, a 350 megawatt power plant. So not even a small unit, we are talking about a substantial facility. And this year was a little bit similar like that, or last year, due to travel restrictions, we were unable to mobilize our teams into certain countries. So we need to switch back to the digital space and do remote commissioning, both for power plants and for vessel engines. I think the general takeaway that these sort of digital tools enabled us to substantially reduce our on-site personnel requirements and operate even in high safety risk areas. And while a decade ago, we have a general rule of thumb that every megawatt installed requires one person at site, as of today, we can operate a 150 megawatt power plant with just a handful of people at site. The other topic which I briefly wanted to introduce is Wärtsilä's role in energy storage and in energy management softwares. So Wärtsilä is one of the leading firms in providing flexible power solutions, and the company is committed to support the transition towards 100% renewable energy-based future. And as part of this initiative, we acquired an American energy storage firm, Greensmith Energy, and fully integrated that into Wärtsilä's energy storage and optimization department in order to support the company to become a top-tier player in the global storage industry. The energy storage market is expected to boom. Bloomberg expects that the storage market will grow 120-fold over the next 2 decades. And I read an IHS report recently which projects more than 4 gigawatt hour new energy storage capacity only in the Middle East, which will mainly deployed in Saudi, the UAE, and Oman. So our energy storage team basically designs and builds pre-engineered energy storage projects. The lithium-ion battery technology is relatively well known. It's mature. Basically, a lot of companies can offer that, but our real strength is the advanced energy management software. It's called GEMS, and it's arguably one of the most mature and the most tested software, control software in the energy industry with 10 years of operation and deployment track record. And basically, it comprises a suite of 5 proprietary tools, which can be deployed throughout the full value chain of electricity. It can be used for planning, for monitoring, for operation, and for optimization. And the real good thing in this GEMS software suite, it not only controls and operates the battery storage asset, but it can basically dispatch the full grid, full network of full fleet of assets which are connected to the software. Having multiple connections to GEMS, the power plant controllers typically get hundreds of thousands of data points every minute. All this data, together with historic data and real life, for example, weather data, it's fed into a cloud solution, and our machine learning algorithms are enabled to constantly update our own predictive algorithms and do and improve forecasting, which results in a great deal of benefits for our customers. With more accurate predictions, they are able to dispatch more renewables. They will curtail less renewables due to lower contingencies, and more importantly, they can react more quickly to frequency deviations. Therefore, they have a better quality of power. And at last, I wanted to bring a real life example. This is we are very, very proud of this project. Wärtsilä was involved. Wärtsilä was leading hybridization of an island project in Portuguese island Graciosa. On this island, there were already deployed solar PV parks, wind farm, diesel generators from other vendor, and a Wärtsilä energy storage asset. And our main role was to hybridize the island's power supply to reduce fuel consumption and increase the penetration of renewables. And even in the first 9 months, we managed to run the island 52 days exclusively on renewables. This island is also equipped with the energy management software, which uses artificial intelligence to control and dispatch various resources. They are fully integrated to the system. The energy management software uses historic production data. It uses optimization on load patterns and gets real live weather data. And all in all is to support the better optimization of that grid. The objective function, again, is to reduce the consumption of fossil fuels and maximize renewables. Initially, we were contracted to reach 65% fuel consumption reduction. And I'm proud to say that we managed to operate the island for 120 consecutive days only on renewables. So I think this demonstrates well that such tools and solutions are ready, they are available, they are scalable, they can deploy anywhere. So basically, the speed of adaptation depends only on the appetite and the ambition of the market. Thank you very much.
Thank you very much, Patrick, for showing us a remarkable, I guess, adaptation, and expertise accumulation through the time. Amazing, all of your work that you've done remotely really has helped get to this point where you can, develop the softwares. Very, very interesting. We'll talk about this a little bit later in the actual questions that I see that some people have sent. So please take a look. And next, I'd like to ask Klaus to please, Klaus, if I can have you on camera, perfect. And I can also have you unmute your microphone and go right ahead with your presentation.
Okay, thank you. So the presentation which I have got is more or less about how to control the grids in general. So in many cases, you have got, let's say, in a grid, you have got the supply, and then you have got this kind of loads, and you have to balance this in real time. And then some cases, some instances, when you have lots of supply systems like small power plants and such, you don't have like a very good control over those, and you actually don't know whether they are active, producing, or they are not. So there's some kind of uncertainties there, and we made this kind of, let's say, software which is helping the power companies in order to solve this kind of problems, real-time, real-world problems on dealing with uncertainty in the grid systems. So if you just change the slide, please. So we are using this kind of fancy things like AI and machine learning, and I just briefly tell about this. So for instance, this AI is actually coming from world of games and simulations, and it's been now actually getting into the real let's say real world applications. And what is the core there is that you have to have, first of all, to apply this kind of systems, you have to have data. And in some cases, some instances, you don't have the proper data about the real world instances, like you don't have a data of such certain systems like power plants or systems which are being, or let's say, a little bit old fashioned. You may not have information. Then if you don't have this information, it is very hard to use this kind of machine learning, because machine learning is about the data. So if you have got data, then you can use this data to make the system to learn about what is happening and what are the pros and cons, what is happening in this scenario, what is happening in that scenario. And the solid data is actually what you either need there. And after you know about by the model, how you know the system is going to behave, then you can actually use this AI-based system in order, top of that, in order to control the system, or maybe to give instruction to the human operator what is need to be done, what is going to happen in the future. And that is something we call a digital twin of the system. So in a big picture, we are using this kind of machine learning and AI tools in order to create digital twins of real world systems. And these digital twins are then actually something you can try something. You cannot actually do trials and errors in a real grid, but you can do that on digital twins. So you can do what if analysis on there, and then that makes you, let's say, more secure about your decisions. And you can also, like in a tricky situation, you can get instructions and try some instances, and then you can get feedback. Okay, if I do this, the system will behave like this. So that is a tool for the human operator in order to manage better these resources they have got. Okay, we can go further. Okay, this here explains how we are using the system. So we have got on the left-hand side, we have got this kind of real-world system, and on the right-hand system, we have got a system which is actually an image of this real-world system, and that is something we call a digital twin. And this is actually something you can play around with your tools. So you can make trials, you can test this system, and it behaves actually exactly similar than in real network is behaving in the background. So that is making it possible to try and test and optimize your systems independently from your real world network. And that is something that is supporting your decision making in real world. Okay, we can go to the next one. Okay, a little bit slow, but it's changing. So there are different ways to use this kind of, let's say, learning processes. So basically what the learning process is, when you are training this kind of system to become a digital twin, there's lots of data involved there, and the training process is like takes a lot of computational power. After you have been training the network, and then after that, it is actually operating as small computational power. The training period could be then speed up with using different kind of boosting system, like we are introducing here, one of those. We have been doing that for a long time, so we have got lots of these kind of technical things in the background, which is helping in order to, let's say, to speed up the learning process. But generally, we are talking about huge amount of data which has to be processed in a complex system, and that takes time. After the training period, we have got, let's say, a system that is open, possible to give you almost like zero time responses, and it is able to work in a very, very, very fast range. So you can have very fast feedback of your actions and controls. So you can even try your own control system against this kind of digital twin. Maybe, yeah, okay, next slide, please. So something about real-world implementations. So we have got a software called Energy Teller, which is actually a component that is able to do this kind of let's say, online, let's say, simulation of the grid. And if you go a little bit further, next slide, we can see how it is behaving. So, okay, it's coming. Okay, so the biggest thing we have been made so far is the simulation model of the total energy grid of Finland, so the whole country. And here the main problem was that in this energy grid we have got lots of small power plants which were old-fashioned, not having a proper connection to the grid. So these power plants are causing uncertainty to the grid because we actually didn't know about the production status of these small power plants. So Fingrid was not able to get very precise estimates about the power production generated by the grid supply. So that causes inaccuracies in the real control and also fluctuations to the grid. So what we did, we generated a model that is able to give a very precise forecast 7 days in advance about the grid status. And the total error rate of the production accuracy is below 5%. So that is a very good, let's say, model compared to the previous ones, and that is actually being used every day in the grid maintenance by Fingrid, which is responsible for grid stability of whole Finland. So we may go further on in this. Okay, so there's something, some technical details, but in general, we did lots of jobs in about how to manage the data, how to create a proper data for the learning process, for the teaching process of the actual digital twin. And I may skip this part of a little bit before and go to the next one. So next slide. Yes, so one of the key findings were there that we were able to, let's say, make modeling of let's say, of some of the power plants which were not available online. So we could model them based on existing power plants and also using weather forecasts, location type of the system, and some other things. So in order to improve the quality of the model, we actually made the background work in which we created this kind of very good quality data for the training process. And after that, we were able to complete this digital twin learning process and get a very good result. Okay, we may go to the next one. So these are like, we can apply the same kind of learning system to control also like smaller items like power plants, buildings, sites and such. So we have been doing this even for, let's say, for supermarkets and shopping malls, like we can also model those, and because they are consuming lots of energy. So once we want to make this kind of balancing between the loads and the production, we also have got this kind of models about this other side, which is the consumer side. So we can do also this modeling. And so when we are running these two models between which one, we can make comparison about, okay, this is our expected production, this is our expected load, and then we can make decisions how to cover these demands. Also, we can model the flexibility which is existing in the consumption side. So we can make flexibility models, and this is also helpful in when we want to avoid high peaks or fluctuations in the system. So this systems has been also tested and verified in like shopping malls, big buildings, and let's say on power plants level. So we may go further having something else. So okay, it's coming. Yeah. So flexibility management, we can see here like this scenario shows how is the accuracy of the model. So in general, we could say almost 10% reduction of peak loads could be achieved when applying this kind of machine learning models for the buildings and loads on the field. Maybe we get the next slide. Yeah. So we have also created control software which allows the system to interact with the load control. So generally, this system is working on cloud level, and so we can combine this kind of load management flexibility to the generation control. So these two things are working parallel in the cloud server, and they can be actually connected as well. But yeah, okay, I think we can take the next slide as well. So this shows about the energy generation forecasting, which is also done in the solar power plant. So it goes like that. So also the production, which is based on like solar or wind, can be propagated, and this can be connected to the general model. Okay, we can take the next one. So yeah, so this was the presentation. So if there's something you want to know and know more details about this, I'm glad to share more information with you. So thank you.
Thank you very much, Klaus. Very interesting presentation. And it's always hard, right, to know how, all this data technology and AI and all has enormous potential. But when you don't work in it every day, you need people like Klaus to tell you how you can deploy it and how you can best take advantage of all those technologies. I'd like to ask also Kamal and Gary to please come to switch your cameras back on so we can see you. How are you doing? So now
Are you sure about that?
Hi, Kamal. Oh, we can't see you, but we can hear you, I think. I think your camera is gone. Oh, there we go. Excellent. So we have some questions that I'd like to ask you now. Okay, so I'm going to start with one that they sent here, and I'm going to let it open to you guys who want to answer it. It says, Usama here says, can you please give us real applications of the digitalization in renewable energy, different technologies and components, for example, PV, wind, CSP, hydrogen. So I guess, in other words, well, he gives many more options, PV cells, resource assessment, inverters, transformers, substations, switch gears. So where do you see applications for digitalization in renewable energy right now? And perhaps, that have the most to gain, I suppose. Who wants to start?
Gary?
Gary, you've been nominated. Please just take the mute of your microphone.
Yeah, look, there's a number of applications that come to mind, but just very quickly, I share one, and then perhaps if we need to, we can go offline. One of the areas we're looking at is using the network that has been modernized and digitalized, so like the 4.0 network that I was explaining, to do some preventative maintenance on some wind turbines. So what we're looking at the moment is how analytics can help the utility predict issues and faults on the turbines before they actually occur, by monitoring temperature, by monitoring sound, by monitoring performance. Because an outage on the turbine is a severe cost penalty to the utility. A preventative maintenance event is a much more efficient cost-saving outcome. So there's just one digitalization example that we're following within Nokia.
Excellent. Thank you very much, Gary. Patrick, Klaus, did you want to add one of your own or two of your own? Patrick, can you hear us?
Yes.
Yeah.
Maybe I would like to add more of a personal experience. I used to work in Africa, and I was in a country which struggled to keep the power system in a balance. They needed flexible power. The country has substantial amount of hydro, which is one of the most flexible assets, but they were unable to dispatch it properly according to the needs because the power plant itself wasn't connected properly to the control room. So there was always a delay, and the hydro plant was never able to meet the exact requirement of the dispatch center, and then they needed additional, typically thermal generation to keep up and to make up for this difference.
Thank you very much. Klaus.
Yeah, well, I would say that in general, to be more aware about the flexibility in the grid and to collect these small bits and pieces of flexibility, which is scattered around the field, like in the buildings and houses, that there you would benefit from a very good functional communication between these assets, and the closer to the real time, the better.
Thank you very much. This is a question from me, if I may. If I was a developer right now, I would be wondering whether there are things that I can buy from you that are off the shelf, that I can implement right away, or whether you are developing something for each of your clients and therefore it requires kind of further study and is it an individual thing that you have to look at, sort of tailor making for each of your clients, or there are things that your clients kind of pick and choose and they're kind of like ready-made? I don't know if that makes sense. Gary, you seem to be... So how does it work? How do I go about and make my energy asset more an maybe if I just talk generically,
as I mentioned in my presentation, our innovation arm is the world famous Bell Labs Institute, who are always looking 3 to 4 years ahead. What do our clients need? What is the energy utility going to need to be doing that we can't support today? That drives the innovation of our product. But what we really are about, and quite generically, is we follow industry standards. So a solution from Nokia is following an international standard, and that provides a quality outcome to the consumer because they have choice and they're not bespoke or locked into a particular vendor or product portfolio. So I think off the shelf, we're a little bit more complex in our solutions than off the shelf. But I think the important thing is the sort of standards, international standards that our solutions follow. So a little bit of an abstract answer, but hopefully gives you the flavor.
If I may add, if you don't mind, I think digitalization is a very broad concept, and it cannot be viewed as a snapshot in history. It is a roadmap, and I don't think any single company can claim today that they can offer a full digitalization story. It has to be an ecosystem play amongst the best of breed in the market, companies that they have decided to invest in this evolution. So I think the most important thing is for a company to develop a digitalization roadmap, where I want to be in the future. What are the use cases that I have today? What are the use cases I'm anticipating in the future? Are there opportunities for me to innovate within that blueprint? Because the days of having a static blueprint are over, and we want to make sure that we have a dynamic blueprint where it allows for the innovation on top of it. So what I think is number one, the most important thing is to have a digitalization framework along with a roadmap toward this digitalization. And then within that framework, there has to be partners that are engaged to make sure that they fulfill the various pieces. Like Gary said, these partners, they need to be compliant with standards. They cannot be providing a system that will lock the user to a particular implementation. They need to be willing to work with each other. They need to be humble partners that are really driven by the end customer requirement, by this digitalization evolution roadmap requirements. I think within that digitalization framework, what you see is there are the use cases. There is the fabric that needs to attend, just like the nervous system in the human body. Digitalization also has a nervous system, which is 4G, 5G communications that connects all of these assets together. It creates those digital twins that will enable clouds to be effective in terms of being able to manage those digital twins in real time and take a copy and map them back into real life. But I don't think myself, Patrick, or Klaus, or Gary can claim that we have the entire story. I think we are enabler to the full vision, and we are good partners for this digital evolution.
Thank you, Gary, for that contextualization. Kamal, sorry for that contextualization. I think it's important to understand, that there is like a much wider strategy here. Patrick and Gary, if you want to, Klaus, if you want to add something here, please go ahead. If not, there is a bunch of questions, so I can go through the questions now.
Well, Klaus. I would say the same. I would agree with this Kamal about this, that we are not alone, let's say, creating the total solution, but for instance, we are currently helping some big cities in India in order to balance and operate the grid network better. In the grid, they have got usually the normal level of let's say, of load is above 80%. And if there's a peak creating, then it very easily causes a power outage or blackout to the system. So by better management of the load and production, actually we can increase the capacity of the grid and also to keep it, let's say, more stable. usually the problem is not the actual power generation, because the power generation is enough, but the grid actually cannot, let's say, supply enough power. There's too much load on the grid. So it is the capacity of the grid that should be maintained as stable as possible. And there we are coming to picture, like providing solutions for this kind of problem solving.
Excellent. Thank you, Klaus. Patrick, yeah, go on.
Yeah, maybe just one addition. All of our hybridization projects are tailor-made solutions. And as I said, the GEMS software suite comprises five different tools. One of them is called GEMS Analyzer, which is used to design the optimal grid infrastructure that helps our customers find the cost optimal energy mix for them, and also helps them to compare various scenarios, run different sensitivities, and then we co-develop the optimal solution in order to best serve the needs of a particular project.
Excellent. So we have 5 questions open, but since it's nearly time, what I think, and we're not going to get through them all, what I think is that we're going to send them to you so you can have a go at answering them directly if you like to the speakers. I see that some questions you've already been answering. There were some very specific ones. So I'd like to thank you very much for being here with us today and for trying to show a little bit of light. Of course, energy teams are, there are all kinds of people out there. There are many people looking at digitalization in the teams themselves. But at the end of the day, it is kind of a tricky, very large industry, that can be taken advantage of in so many different ways that it's very difficult sometimes to know what is the best solution right now. So I think what I have learned today is that this way is to be in touch with the guys that have the know-how as soon as possible, so that you can build a picture for what you can and should do. And, we had a here from Nokia, we heard from Varsila, we heard from BTT that have some of those answers that you're looking for. And, 40 years ago, we had solar energy, sun, and we didn't know what to do with it. It was there. It didn't have a value, it was just there. But now we've learned that is actually, we were wasting a value, we need to actually collect that and create energy. And this has been a long time going, it's not happened from one day to the next. For the longest time, we were not paying any attention to solar energy other than to dry clothes. So now we're at the position where, we need to take advantage of all that data that we're creating. We need to get better. We need to get cleverer, because there is a lot of value in that data and in the way that we operate that we can still unearth to make our assets more competitive. So please, I'd like to ask you to, if you're going through digitalization, to get in touch with these guys, and speak to them directly. And thank you very much to Kamal and Gary and to Patrick and Klaus for your expertise today, and also to Business in Finland for helping the creation of this content. See you next time. Thank you.
Thank you very much. Goodbye.
Bye-bye.
Bye.